14, randomness and probability, free throws. Okay, turning your packet to the how good is Miss Gallus at free throws. So in the first part, what we're trying to do is we're trying to see how much this particular shooter is good at free throws. So my guess on these particular throws is to see do you make or miss, and then what percentage do you make and what percentages do you miss, and then how many shots do you take before you're actually comfortable. Now you see the data here that I have already. X is miss and check is make. And for 10 and above, I just did a fraction on some of them, but for 40%, 4 out of 10 or whatever, but mainly getting the percentage, and you can see how the percentage goes. Now, the way that I use this is I used an app called the Stat app here on the applet here, and I just did one shot at a time and then another shot and then another shot, but I'm just going to go ahead and fast forward it to 80 shots. And what this app does is basically this app says that this person comes to them and says, hey, I'm an 80% free throw shooter. That's why there's a line right there at 80%. But they said, well, I'm actually going to run a simulation, or I actually want to see you shoot it and see how accurate you are. Well, so the way that we are shooting it is that if I am, this is what I actually am. This is the percentage I actually am. So we're going to see here, I'm going to hit the true probability. The true probability of the shooter is 65%. So what that means is that 65, when I'm writing up a probability or we're doing a probability, what that actually means is 0, if I do, 0 to 64, so 65% is going to represent a make, and then 65 to 99 would represent a miss. And then what that would represent is in a random digit table, every time I came up with one of these numbers, that would mean I made the shot, and it would come up as a make. And every time one of these two-digit numbers came up, that would come up as a miss. And this is what a simulation would look like. So you can see as I continue to go, it does get closer and closer to my actual probability, which is right here, because this person's 65%. So clearly, this is the 80% that the free throw shooter claimed, and it is clearly not that. But let's go back to ours. So ours here had a percentage, and this is the percentage, but when I actually looked, the actual percentage was 45%, and you can see that it was up and down, up and down, up and down. Now in the short term, you see where it's unpredictable, because my percentage is all over the place. But you can see in the long term, that gets closer and closer and closer to the actual true probability. And if I go back to my app here and I do another 80 or so, and I keep shooting, the more and more I shoot, you're going to see that the closer and closer to my actual shots gets to my true probability. Remember, this true probability didn't just happen overnight. The true probability is over a long period of time, a full season of games. All right, so number 4 says, how could you make your guess more accurate, more free throws? And that is called the law of large numbers. I'll give you the formal definition of law of large numbers in just a bit. So this is the interpretation. If Mrs. Gallus takes many, many free throws, about 40% of them will be makes. Now, please make sure that you have all of these particular things that are important. So for this one, you will be interpreting probability on your AP test and on my test, but many, many or lots of free throws, and then about. Because when you look up here, it's only exactly at 40% right here on that green line. But you can see most of the time it's not exactly 40%. It's somewhere a little bit above or a little bit below. So the two concepts that I want you to understand is the first on probability is probability is long run relative frequency. Always it's between 0 and 1. In short term, it's unpredictable, and on long term, it's predictable. And one thing I do want to add here is that that each individual probability, that all events in a sample space add up to 1. So if I have the probability of, let's say, a balloon, I don't know, and let's say the balloon is going to be whether I choose red or whether I choose blue or whether I choose green. Let's say that those are the 3 choices, and I think there's a 20% probability someone chooses red, a 30% that they choose blue, and a 50% that they choose green. This is a valid probability because each individual probability is between 0 and 1, and all of the probabilities, all of the events add up to 1. So those 2 things you have to remember to make sure that you, if it asks if it's a valid probability, those are the 2 things to check and the 2 things to go ahead and write down. All right, the second thing is law of large numbers that I just mentioned, but basically it says if we do something a lot of times, many repetitions, the proportion of the desired outcomes will approach its actual probability. The more times I do it, the closer it's going to be to my actual probability. Go ahead and do the check for understanding if you have not. And the check for understanding ask you particularly to analyze what 55% probability means. And here's the main thing to make sure you have. If Pedro drives to work many, many times, so there's that, making sure you say lots of times. And then about 55% of the times will hit the red light. And the other thing that you're going to see is that just the context, the talking, what context means, what am I talking about in the problem? I'm talking about Pedro driving and getting stopped by red lights. Okay, for number 2, 0 is never occur, 1 is always, because that's 100%, 1 is 100%, 0 is 0%. Anything unlikely is anything that is less than 50%. Obviously, very unlikely is something that's really close to 0. More likely is anything that's over 50%. And 60% and 99% are both of those. Number 3, the probability of is, the doctor's wrong because probability is unpredictable in short-term situations. The probability of the next baby is still 50%. And remember that each birth is independent from the next. And since they're independent from each other, remember that each one is 50%. Exactly. All right, thank you very much for listening to the lesson.